Okay, good morning everybody. Pleasure to be here in Berlin, and two fantastic presentations, really inspiring. So I hope I can keep the standard high. I'd like to talk to you today about smart vehicles in a smart world, and specifically about how we're using data to predict road safety hotspots and to improve road safety generally. But before I do that, I'd like maybe just to take 5 minutes just to give you a little bit of an overview on Ford Mobility and our approach. So Ford Mobility is a division of Ford Motor Company, and we've been created specifically to develop smart mobility technologies and services and to invest in promising mobility-related ventures. We're a global team led out of Dearborn in the US. The European team is based in London, and we've got colleagues in Germany and in Spain. And together we're piloting and exploring a wide range of smart mobility work streams. So, where does the motivation come for smart mobility? Well, our global global chairman, Bill Ford, gave a TED talk back in 2011. And he stated that the mobility model that we have today will not work tomorrow. Now, back in 2011, that raised a few eyebrows in the auto industry, and it raised a few eyebrows, frankly, within Ford Motor Company. And he based his conclusions on 4 key global trends that the audience here will be very, very familiar with. And I think Francesca referenced some of those in her speech. And that was urbanization, the fact that more and more people are moving into cities, the growth globally of the middle class and their aspirations to own private vehicles, air quality as a key driver of policy, and then changing customer attitudes. And his hypothesis was that existing city infrastructure was unable to support the predicted rate of population growth, the increase in public demand for private vehicles, and the number of vehicles that would result from that. And his conclusion, essentially, the consequence was global gridlock. And so therefore, Ford Motor Company needed to be leading, not just in terms of developing smart vehicles, but equally being involved in the discussion around developing smart infrastructure. So that was, as I say, back in 2011, and 8 years have elapsed. And I think in the period since Bill Ford gave that then controversial talk, there's been a real paradigm shift in the auto industry. And few would argue that the industry now is really in a period of huge transition. Again, few would argue, it's probably the biggest challenge and most fundamental period of change that the automotive industry has faced in the last 100 years. There's 3 key themes that I would point to. Electrification, and I was at the Frankfurt Auto Show yesterday, and if anyone's in any doubt about the direction of travel for the auto industry, I think if you walk around some of the stands there, the evidence is there to see. Without exception, every OEM is on the transition towards electrification. Second theme is digitalization. The fact that vehicles are increasingly connected, and the opportunities that presents. And then the final issue is the customer expectations and the change in the assumptions around the ownership model. So owning a car was the assumption perhaps a decade ago. That's no longer the case. New models for ownership are increasingly coming to the fore. Whether that's, Fujitsu mentioned, Christoph and Hugo mentioned about car sharing. Increasingly evident across the industry. So, 3 reasons that we're really in a period of substantial change. And I think the way we characterize it is that we're going from designing cars to designing and selling mobility services. We're moving from essentially product design to systems design. So Bill Ford talked about smart vehicles in a smart world, and it's through that lens that we like to visualize our own strategy today. So today we're talking about smart connected vehicles, increasingly provided integrated services for the customer, and that's both for individuals and also commercial customers. As we move towards the smart world that Francesca referenced, I think we're talking about being part of that ecosystem, part of that offer to the customer, and working very closely with cities to be part of that smart world. And my job within Forward, and it's very deliberate that we are focused on developing those collaborations with cities and other stakeholders. So what does that actually mean, and what are we actually doing within Ford Motor Company, and what activities are we engaged with? Well, we're looking at a number of different work streams, and that's both here in Europe and also in the US, and that's opportunities around vehicle data and connectivity. I'm going to come back to that in a moment. We're looking at things like curb space management. How do we optimize the use of the curb? How do we reduce the environmental impact of last mile delivery? Looking at micro-transit services and micro-mobility. Cloud-based services, such as the Transport Mobility Cloud. Again, it was referenced in both the prior presentations. We are Europe's leading commercial vehicle company. The Transit is a nameplate that you've probably all heard of. And we're developing a range of connected vehicle services through part of the organization called Ford Commercial Services, to help customers, commercial customers, manage their fleets more efficiently and more environmentally friendly. Ford Pass modem technology is a technology that's included in every new Ford. So from next year, 90% of Ford products sold globally will have an embedded modem. And that rapid proliferation of that technology really provides a unique opportunity to deliver intelligent mobility solutions. Again, I'll come back to that. Our investments include Autonomic, which is the part of the organization looking at opportunities around the mobility cloud. Translock, a micro mobility company, and one of the most recent acquisitions is the US electric scooter company Spin. So I'd like to now focus on just one of those work streams and talk to you about city data solutions and some of the exciting work that's been led by my colleagues in London. So big data. I think big data is one of the biggest opportunities that we have near term to really move the needle on mobility, both within cities and intra-city. Connected vehicles, and I talked about the fact that more and more vehicles are connected, and that's happening very, very quickly, provides a huge source of new data, and that's very, very deep data. So there's all sorts of signals coming off the vehicle. We're not just talking about where the vehicles are, we're talking about every aspect of that vehicle. And we've got a team based in London, the City Insights team, that's focusing on this question. And how can we develop data-driven products and services? At the core of the philosophy is the idea that the vehicle is a distributed sensor. If you imagine a vehicle that's connected, GPS data obviously, but every other element of how that vehicle operates is available to us. And we wanted to really apply big data analysis to see if we could solve specific problems. I think there's lots of generic conversations about big data. And less frequently do you talk about or do you hear about the specific opportunities to solve problems, and that's really what we wanted to look at. So back in 2018, we initiated a pilot in London to really look at some of those opportunities. So the pilot involved connecting 160 plus light commercial vehicles, and these were vehicles that were in commercial use with a wide range of operators. So companies operating service businesses, delivery businesses. We really tried to make sure that as many different types of business were represented. 15,000 days of vehicle operations over just short of 12 months. And the fleet covered more than 1 million kilometers during that period. And we collected a fairly extraordinary 500 million data points during that period. So it was a substantial exercise. We then using some of our in-house data analytics capability, did quite a bit of analysis on that. And as a consequence, we published a report. Now, from the very beginning of that trial, we worked very closely with Transport for London. So back to the point about engaging with cities, we're very keen to understand what city policy priorities and issues are. So before we started this, we talked to TfL, and TfL were a partner in this particular project. The Mayor's transport strategy, so the Mayor of London's transport strategy, identified a number of individual areas that were particular focal points for London. And Francesca, perhaps when we get to the Q&A, you can tell me whether these are common to Barcelona. But road safety, traffic retiming, issues around where do you position electric vehicle charging infrastructure as you move forward, looking at transport mode shift analytics, so looking at perhaps a private vehicle or private van, equally looking at other modes and being able to advise the public what was the most appropriate mode to use. Alternative road traffic metrics around things like school holidays and other periods. So it was a wide range of different issues that we looked at. The issue that sort of popped out of this study and was of particular interest to the Mayor's office was road safety. And I'm going to play you a very short video in a moment just to explain that. But before I do, there's a lot of numbers in there, and there's a lot to take in. So maybe just very briefly before I play it. The pilot involved collecting data from vehicles, and that was, yes, GPS data, but it was also throttle position, speed, engine RPM, braking severity, steering angle. So a select number of signals from the vehicle, and we can pull hundreds of signals off the vehicle. But just to give you an idea of the types of information that we pulled. And this gave us the potential to identify how the vehicle was being driven. And from that, we, together, by using some smart algorithms, we're able to predict the higher probability of accidents occurring. Now, with that information, we then overlaid that on top of historical accident data from Transport for London. So this is publicly available data, and that looked at all accidents in London. It looked at serious accidents in London, and it looked at fatalities. And we overlaid our data set on top of that data set, and we were able to draw some quite close correlations. And the hypothesis being from that, if you can draw correlations, you can then develop a predictive tool. And that's what we're working on. So just maybe with that brief introduction, I'll play the video. Okay. So just pulled a few figures out of that that video. So 37,000 accidents in central London. They were 2016 numbers. We've got more recent numbers. I mean, when you think about that for a moment, that's all accidents, of course. That's everything from a minor shunt through to a fatality. Every single one of those has a consequence. Even the most minor incident has a consequence in terms of congestion, in terms of pollution, in terms of disruption, in terms of impact on economic activity. So when you think about it, 37,000 incidents, that's phenomenal. A couple of other figures. I think it's 102 pedestrian fatalities in 1 year in London, in one city. 15 cyclists killed in London in 2016. This year, they're already ahead of that target in London. I say target. You know, as cycling has increased, I think growth in cycling in London's about 8 to 10% per annum. The number of cyclists killed in London is increasing at the same rate. You know, how is that acceptable? It's when you see these figures starkly, it's pretty phenomenal. So, you know, that's why we are motivated to do something about that, and why we think vehicle data can really move the needle. You're not going to move the needle with just uninformed infrastructure change. You need the data to make those informed choices. So what have we done over the last 6 months? We've taken this information, and we're talking to, not just to London, but to other cities. We're partnering with Valencia, with Cologne. We're talking to other cities around Europe. And I've got to say, there's been a huge interest in this particular part of the study. Road safety, of course, is a universal theme. We want to be 100% sure that what we are concluding is correct. So what we've done is we've actually worked with a civil engineering company called Traffic Watch in the UK, and having identified where we believe the hotspots are, correlated that with the historic data, Traffic Watch have gone out and then surveyed some of those areas, and from that we've been able to really confirm that what we pick up with the vehicle data is true on the ground. So what we're seeing is driver behaviour and road conditions contributing to accident situations. So drivers, cyclists, jumping traffic signals, illegible road signs, poor road surface conditions, poor markings, things like sunken manhole covers causing cyclists to swerve into the path of traffic, narrow lanes creating conflict between road users. Now, in many cases, some of those are simple and low-cost opportunities. Not all of them, but many of them are, and that's the sort of information that we can feed back to cities, to traffic authorities, and to other stakeholders. So, you know, just the way forward. We're developing this technology. We're looking to develop a dashboard that will be of use to planners, to emergency services, to cities. As we increase the number of connected vehicles, and I'm not just talking about Ford connected vehicles here, I'm talking about all connected vehicles. OEMs are all on, you know, they're all on the same trajectory in terms of connecting vehicles. We have a huge opportunity to unlock more and more possibilities. The safety example I've given really is just the tip of the iceberg in terms of the opportunities that vehicle data can provide. And really, by harnessing the power of data, you know, we believe that we can develop a range of innovative solutions and a portfolio of products that will deliver real-world benefits. So I will stop there. I look forward to taking questions and joining the panel. Thank you very much.